All right, guys, welcome. So, last one today, 2i. So we will get into that. I'll just take you through where we left off yesterday. So we ended up here, and what I'll talk about, I'll talk about the strategy to get the solution, and then I'll talk about when you encounter a problem like this, how to deal with it in a test situation. So this is where we sort of finished off, and I was sort of scratching my head going, well, what can we do here? So one strategy that we cracked afterwards is we can multiply both sides by lnb to move that up here. So we'll have lnb, ln3 equals ln2, ln of 1 plus b. All right, and then ln3 or lnb, whatever it is, it's just a number. Okay, so then we're going to use this rule, which is when we have a number out front multiplied by ln, we can take it to the power. So I'm going to write this like this, and over this side, ln of 1 plus b to the power of ln2. And from here, we've only got one possible solution for b, one possible solution that satisfies the equation. And we can see b equals 2, and 3 is equal to 1 plus b. So b equals 2 in that circumstance as well. So we determine the value of b, and then we can go back and plug it in where we had a to get the value of a. Now this process that I performed is different from what the textbook work solutions will present to you. They stop early on and they use a guess and check method. And that's perfectly acceptable, but I think it's better for us to solve through for a variable and then perform the algebra involved in solving for it. Anyway, that question is not going to be in the test. That's more similar to 2C.2 question 7, where there's more algebra involved than you're required to demonstrate in the test situation. I've got a worksheet today of these kind of questions that you can sort of expect. Okay, so we'll hand that out.
In the worksheet, is it more like test questions? Or
more like test questions, yeah. So I think there's really 2 questions in the textbook that are sort of beyond the scope of what you need to do. This being one of them, and the other one being from 2C.2 question 7. All right, so let's get into second derivatives today then. And what we're doing in second derivatives is we're just performing the first derivative. All right, we obtain the function, and then we differentiate it again. So if I'm going to differentiate this function, I'm going to first express it as a power of n. And then to differentiate that, I'm just going to use the power rule. So that will be our first derivative. And then what we do is we're going to differentiate it again. So dy on dx is the first derivative, and the notation we use for the second derivative is d squared y on dx squared. That means second derivative, hence the 2's. And the third is just going to hang out the front, right, because it's a number multiplying it, and I'm just differentiating that using the power rule. So I've got x to the minus 2 on 3, minus 2 on 3, x to the power of minus 2 on 3, take 1, minus 5 on 3. Okay, and that's a perfectly acceptable answer. So those numbers will multiply and can be simplified, but differentiate without simplifying. Okay, good. That's right for A. All right, on to B. Now, when you're looking at this, hopefully you're looking at that and going, I should use the quotient rule. I've got one function divided by another. And you could use the quotient rule, but if we differentiate it using the quotient rule, when we get to the second derivative, we'll have to use the quotient rule again. And that's a perfectly acceptable way of doing it. It'll just take much longer. We've always got to look for the simplest way of doing things. And I'm looking at the top and the bottom, and I'm going, because we just have x's, and we only have one term here, we can split that denominator and simplify it using index laws. So we absolutely should do that if we can. So the first thing I'm going to do is split the denominator. And this is a skill that we actually covered when we were doing simple differentiation. Right, and square root of x I've expressed as x to the power of a half. And now, because these have the same base, we can perform the top power, take away the bottom power, that index law. A to the m on a to the n, top power take the bottom power. So it will simplify to 2 take a half, that will be 3 on 2. And over here the power is 1, alright, x to the power 1 take a half will give you half. Okay, so we've performed a step of simplification, right? And this is going to make the differentiation much easier. So, being very clear, this is my function, alright? Now I'm ready to differentiate. Differentiate everything in one step. So, x to the n, x to the n take 1. Okay? We'll pull that 3 on 2 out the front. X to the power of 3 on 2 take 1 will give us half. And then we have the 3 hanging out. Okay, the 3 is just a number multiplying through. It's just going to stay there. X to the half will become half x to the minus half. Okay, that's the first derivative. Let's get the second derivative. So the way we denote the second derivative when we're using f of x is f dash dash of x. Okay, 2 dashes for the second derivative. Alright, so I'm given f of x, so I'm going to answer in terms of f of x. Over here I'm given y, so I'm going to answer in terms of d squared y and dx squared. Okay, so you won't be penalised if you mix them up, but you will be penalised if you just write equals, 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 because they're not equal. You need to be very clear what's the function, what's the derivative function. Okay, so then I'm just differentiating again, right? So the 3 on 2 hangs out, and the derivative of x to the half, half x to the minus half. Over here we've got the minus 3 times a half. That's just going to hang out as well because it's just numbers multiplying, and we're differentiating x to the minus half. Okay, so we have minus half x to the minus 3 on 2. Close our brackets, and we've completely formed the second derivative. Now what's good about this procedure is we can go straight from the first derivative to the second derivative. If we're using the quotient rule, we would have to perform it twice, and you can do it, but it'll probably be double the amount of work. Alright, but it still works, it's fine, it'll just take more time. Okay, that's B. Let's move on to C then, where we have cos of e to the x. So we have y equals cos of e to the x. So this is a good recap of what we were doing yesterday. If we have cos of f of x, the derivative is minus f dash of x, sine of f of x. Okay, so we can differentiate straight away, there's nothing to simplify. So cos of f of x, we need to put the negative derivative of that out the front. The derivative of e to the x is just e to the x, and I said it's negative. So that's that part, and then we just have sine of e of x. Okay, that's our first derivative. But in order to obtain the second derivative, we're looking here, I've got minus e to the x multiplied by sine of e to the x. Minus e to the x times sine of e to the x. This is a product rule. Okay, we have two functions multiplying one another. U times v. Now, derivative of e to the x is just e to the x, so that's not changing. And when we have sine of f of x, we go to f dash of x cos of f of x. Okay, so this component here, when we differentiate that, we get e to the x cos of e to the x. Okay, so write these out. Get this part correct, and then you're just copying it in the next step, aren't you? So we'll answer the second derivative, d squared y on dx squared, u dash v plus u v dash. All right, and don't worry about negatives and so forth, just use brackets, okay? Just use brackets, then you don't have to think about, is it going to be positive, is it going to be negative? U dash V plus U V dash. Very good, so that's C. Excellent, let's move on to question 2 then. And you might think question 2 looks like one of those sort of challenging ones where we've got these unknowns to find. And it's one of the easier ones we can ask. So we have y is ax squared plus bx plus c. Now who can tell me what kind of equation is this? Quadratic, really good, okay? It's a quadratic, the leading power is 2, excellent. So we're going to determine the equation of a quadratic that has these properties. Let's list them. We have f of 0 equals 3, f dash of 2 equals minus 5, and f dash dash of x equals minus 4. Okay, so we just, what do we do when we're confronted with a question like this? We use this information. So let's start with this one. We've got f of 0 is 3. When I put 0 into this question, okay, so we're given y, but we can write y equals f of x, it's absolutely fine. F of 0 equals a times 0 squared plus b times 0 plus c. And f of 0 is equal to 3. Alright, that's 0, that's 0. I've got c equals 3. I've already found one of those variables. Okay, next let's find the derivative function, f dash of x. Now, when you differentiate this, a and b are just numbers, so you just treat it as if it was a number, all right? The derivative of ax squared will just be 2ax. All right, that power just comes out the front, doesn't it? 2ax to the power of 1. And the derivative of bx is b. So that's our derivative function. And we have f dash of 2 is minus 5. So let's use that. So this is going to give us 4a plus b equals minus 5. And we can't solve that yet because we have 2 unknowns. We don't have anything to do with a and b, so we've got nothing to do there. Let's move on and use the next piece of information, f dash dash of x. So that means I'm finding the second derivative. I'm differentiating the derivative. That's going to be this one. So the derivative of 2ax will be 2a. The derivative of b is 0. Alright, 2ax is the same as kx, the derivative of kx is k, derivative of 2ax, 2a. And then we're told the second derivative, we don't even have to put an x value in there, the whole second derivative is equal to minus 4. This gives us a is minus 2. A is minus 2, let's chuck that in here. We'll get b is positive 3. Alright, plus an 8 to both sides. And then we'll just make a statement. Therefore, the quadratic is minus 2x squared plus 3x plus 3. We've got a is minus 2, b is 3, c is 3. Really good. Okay, so second derivatives. Let's get cracking on this exercise, and we'll dedicate the first half of this lesson to second derivatives. Before we go off to recess, I'll find out what revision resources you want printed so we can get started this weekend. And then when we come back, we can start talking about the test and so forth.